around you right now. Somebody might be moving or fidgeting in your classroom. A light above your head might be glowing. Maybe there's a fan blowing air on your face, or you can hear the faint hum of a computer. All of these things involve energy. But what is energy? What are the different types, and how does it work? We get into all about energy right now. Scientists describe energy as the ability to do work or cause change. Put simply, energy makes physical processes and changes possible. Energy comes in many different forms and can move from one place to another or change form from one to another. Let's start by looking at some of the different types of energy. Our first type of energy is kinetic energy, which is known as the energy of motion. If an object is in motion, it has kinetic energy. A rolling bowling ball, a flying bird, a person running, and even moving air all have kinetic energy. The larger an object is and the faster that it moves, the more kinetic energy it can have. That's why a fast-moving baseball has a lot greater impact than a slowly rolling marble. Next up we have sound energy. Have you ever put your hand on a speaker while it's playing and felt it shaking? That shaking is caused by vibrations. When an object vibrates, it can create sound waves that carry energy through a material such as air. Sound waves need a material to pass through, though. You won't hear any sound in space because there's no air and therefore no material for it to pass through. When you strum a guitar string, tap a drum, or speak, you create vibrations that travel through the surrounding material. When those waves reach your ears, your hearing system converts the vibrations into signals that your brain interprets as speaking, music, or other sounds. Sound energy! I did that for science. Deal with it. Our next type of energy is radiant energy, which is energy that's carried by electromagnetic waves. Visible light is the part of this energy that our eyes can detect. The sun is Earth's primary source of radiant energy. We also encounter visible light from glowing light bulbs, campfires, television screens, lightning, and even some organisms like fireflies. The thing about light is it travels incredibly fast. Can't beat me in a race, I know that. Here we go! Whee! In a vacuum, like much of space, light moves at 300,000 kilometers, which is over 182,000 miles per second. Faster than anything else can carry information through space. Next up we have thermal energy, which is associated with the microscopic movement and interactions of particles in matter. Even when an object looks completely still, the particles inside are constantly moving. As the temperature of an object increases, its particles generally have more microscopic motion. You experience thermal energy when you hold a hot cup of chocolate, when you sit next to a fireplace, or if you step out onto pavement on a hot sunny day. You can actually produce some thermal energy right now by rubbing your hands together, because friction will transform some of your motion energy into thermal energy. Toasty buns! Next up we have electrical energy, which is associated with electric charges, their movement, and their interactions. Electrical energy powers much of our modern world. Electric currents travel through wires called conductors to charge tablets, power microwaves, refrigerators, all that kind of stuff. We also see examples of electrical energy in nature during powerful lightning strikes. It's not Zeus and it's not Thor, it's nature. Energy can also be stored, often as our next type of energy, potential energy. Potential energy can be transferred or transformed later. A stretched rubber band stores elastic potential energy, while a roller coaster car at the top of a hill has gravitational potential energy. Another important type of stored energy is chemical energy. Food has chemical energy associated with the molecules in it. Your body's digestive system uses chemical reactions to release and transform energy from food, so you can move, grow, think, and really do everything else. Batteries also store chemical energy, which can be transformed into electrical energy when the device is turned on. Now here's one extremely important rule about energy. Energy cannot be created or destroyed. It needs to be transferred from one system to another or transformed from one form to another. This is called the law of conservation of energy. You cannot destroy me, I am energy. Think about what happens when you ride a bicycle. You begin with chemical energy from the food you have eaten. Your body uses chemical reactions to transform some of that chemical energy into mechanical energy that helps you move your muscles and turn the pedals. As the bike moves, some of the kinetic energy is transformed into thermal energy because of the friction between the tires and the pavement. Some energy also becomes sound. Yeah, so what if I still have training wheels? Don't judge me. Or we can also think about a toaster. Electrical energy is transferred from the outlet to the toaster's circuits and heating elements. The heating elements transform electrical energy into thermal energy, which heats and toasts the bread. Because the elements become extremely hot, they can also glow and produce visible light in the form of radiant energy. Every moment of every day, energy is being transferred and transformed all around you. The sunshine warms your skin. Food provides your body with chemical energy that it can then transform into other forms of energy. Objects in motion have kinetic energy, and objects in certain positions or arrangements can have potential energy. So take a look around your classroom or your home. Can you spot some examples of energy being transferred or transformed? You might be surprised by just how many examples you can find. Thanks for watching. I'll see you next time.